In this chapter, we will be using calculus as a tool in curve sketching. In this video, we'll be sketching the function f of x equals 2x to the 5/3 minus x to the 4/3.
Okay, everybody, let's take a look at some more. So let's take a look at f of x is equal to 2x to the 5/3 minus x to the 4/3. And just like we did before, the very first thing that we're going to look at here is we're going to look at the domain. Okay, now notice it's not a rational, okay, so I don't have to worry about division by 0, so I'm not looking for non-permissible values in that sense. What I'm looking for here, though, is I've got these rational exponents. So what I'm seeing here is 2 cube root of x to the 5th minus the cube root of x to the 4th. And so then I got to ask myself, are there any real numbers that I can't take the cube root of? And the answer is no. So actually, it turns out the domain here is going to be all reals. Okay, there is no gap in the domain. Next, let's take a look at the intercepts. Okay, so first let's take a look at the y-intercept, and I do that because I'm lazy, because all I've got to do here is set this thing equal to 0. And when I do that, I get the cube root, 0 to the 5th is 0, cube root of 0 is 0, multiplied by 2 is 0, 0 to the 4th is 0, cube root of 0 is 0, 0 minus 0 is 0. This is awesome. So I know right away here that this thing is going to go through the origin. Okay, so I've got the y-intercept there at the origin, which is great here. Now let's take a look at the x-intercept. And I do that by, again, setting the dependent variable equal to 0. So that's going to be 2x to the 5/3 minus x to the 4/3. So this is an equation that I should be solving, and I'm going to do that by factoring. And so just think back to an earlier chapter in this course here. What we did to factor is you took out the common x there, but to the smallest exponents. We're going to take out x to the 4/3. That is going to leave me with, what have I got here? This is going to leave me with 2x, and let's just think about like this. That's going to be x to the 5/3 minus 4/3 is going to be x to the 1/3 minus 1. Okay, so where does this go to 0? Well, this goes to 0 where x goes to 0, and I already got that. Okay, I've already got the origin there. But it also is going to go to 0 where this factor right here goes to 0. So now what we want to do is we want to solve for this one right here. Let's take a quick look at that. 2x to the 1/3 minus 1 equals 0. So 2x to the 1/3 would equal 1. Divide by 2 so that we get that variable by itself. That's going to be 1/2. Okay, and so now I'm looking at where x is going to equal the cube of this, which is going to equal 1/8. There we go. Now, let's go back and, I'm sorry, just taking a look at something, just making sure everything lines up here. So 1/8. So it's going to 0 at 0, and it's going to go to 0 at 1/8 there. Now, let's take a look at symmetry. So symmetry, remember what we're going to do here is we're going to plug in negative x, and we're going to see what happens when we do that. And if you plug in negative x into this one, we're going to get 2 multiplied by the cube root of negative x to the 5th minus cube root of negative x to the 4th. Okay, well here, a negative to the 5th is going to stay negative. The cube root of a negative is a negative, so I'm going to factor that out. So negative 2 cube root of x to the 5th. Okay, that's looking good. That's looking a lot like it's going to be odd. Except right here, negative x to the 4th, that negative is going to disappear, and so we're left with negative cube root of x to the 4th here. So although it popped out here, it didn't pop out here. This isn't the same as negative f of x. It's also not the same as f of negative x. Like it doesn't, or sorry, f of x, because the negative didn't completely disappear here. So this is neither odd nor even. Okay, neither odd, whoops, sorry, you can't see it, neither odd nor even there. Okay, let's keep going here. Let's take a look at asymptotes. And this is not a rational, and so we can assume right away that there's no asymptotes. So that was easy. Now let's take a look at intervals of increase and decrease. Okay, increasing and decreasing. So what we had to do now is take the derivative. So y primed is going to equal 10/3 x to the 2/3 minus 4/3 x to the 1/3. All right, so there's our expression for the derivative. Now we're interested in where this becomes 0, because remember that will be the boundary points between the spots where this thing is increasing or decreasing. Okay, what am I going to take out of that? I would factor out common 2/3 x to the 1/3. Okay, and when I do that, I will get here, if I factor that out, I'm going to get 5 x to the 1/3. Okay, when I take that off out of the x to the 2/3 there, minus, I'm going to be left with a 2, and that's it. Okay, because I took out the x to the 1/3. Good. So now when we set this equal to 0, when we replace the y prime with a 0 here to look for where this thing changes signs here, first of all, it's going to change signs at 0. Okay. It is also going to change signs where this factor goes to 0. Now let's just take a quick look at that. Okay, so 5x to the 1/3 minus 2 is equal to 0. We'll bring the 2 over, divide by 5. So x to the 1/3 is going to equal 2 over 5. And now cube both sides, and that's going to occur where x is going to equal 8 over 125, 8 1/25. All right. So what we've got here on our number line here, we're going to have 0 and 8 1/25. Let's take a quick look here. If we look at our derivative here, if you plug in a negative value, okay, into this, you're going to get a negative value. If you plug in a positive value, you're going to get a positive value. So essentially, this factor right here is going to be negative to the left of 0, positive to the right of 0. 5 times x to the 1/3 minus 2, this is going to be negative when it's to the left of 0, and it's going to be positive to the right of 0. Okay, but it's going to produce a value, when you multiply by 5, it's going to produce values that are going to be quite small when their values are in between 0 and 8 1/25 there. So this thing is actually going to be negative here. It'll be positive here and positive here. Negative here as well, and positive there. So altogether, the function is going to be positive here. Whoops. It will be negative here. And then they're both going to be positive on this side here. So it's going to be increasing, decreasing, increasing. So remember, let's summarize that. Let's take a quick look at that here. That means the derivative, remember, is positive. That's going to be on the interval negative infinity to 0, together with the interval from 8 1/25 out to infinity, which means the function is going to be increasing. I'll just put it over here. That means it's increasing on the interval negative infinity to 0, inclusive, union, 8 over 125 out to infinity, and again including the 8 over 125 here. We know that the derivative is negative on that interval from 0 to 8 over 125, which means that this graph is going to be decreasing, right, on that interval, the closed interval from 0 out to 8 1/25. Okay, good. So now we can use this to help us find our max and min values. And actually that should be pretty clear. We're going to get a max here, and we're going to get a minimum here. Okay? So let's go through and take a quick look at this. So we're going to get a maximum, okay, at the origin, 0, 0. That's a point we'd already found before. Then we're going to get a minimum at, now I got to take a quick look at this. It's going to happen where x is going to equal 8 over 125. And I actually don't have a calculator handy here. So that's okay though. Let's come back up to here. So if I plug 8 over 125 into this, okay, I am going to get 2/5 when I take the cube root to the 5th power. So this is going to be 2 multiplied by 2/5 to the 5th power minus, this is again, the cube root is going to take this down to 2/5 to the 4th power. So it'll be 2/5 to the 4th power. We can factor out 2/5 to the 4th there. Let's just do it over here. 2/5 to the 4th, and that is going to leave me with 2 multiplied by 2/5 minus 1, which is going to be 2/5 to the 4th power. That is going to be 4/5 minus 1, which is going to be negative 1/5. So this is going to be negative 2 to the 4th over 5 to the 5th. See, my issue right now is not off the top of my head knowing what 5 to the 5th is. That is going to be... Okay, so this is going to be negative 16 over 3,125. Awesome, there we go. So this is going to happen at 8 over 125, comma, negative 16 over 3,125. Whoa, that's a nasty looking number there, but so be it, whatever. Now, let's take a look at 8. We're looking at concavity. So we're going to take the second derivative. So what do we got here? We're going to have y double primed is going to equal 20/9 x to the negative 1/3 minus 4/9 x to the negative 2/3. Now that's an interesting result because all of a sudden that introduces, because of those negative exponents, it introduces an undefined value there. So when I'm looking for where this is going to equal 0, what I'm going to do first of all is I'm going to factor out the 4/9, but I'm also going to take out the smallest exponent, x to the negative 2/3. And when I do that, that's going to leave me with here 5, okay? And I just want to double check that I'm okay with that. Yep. And then I'm going to take out, so this is going to become x to the positive 1/3 minus 1. Now, this thing here is going to be undefined, undefined at x is equal to 0. Okay, that's an interesting result. Okay, that the concavity has an issue here. It could be changing at 0. It's also going to be equal to 0 where this function here goes to 0. Now let's just in our heads figure out what that's going to be. That's going to be bring the 1 over, divide by 5, so that's the cube root. So then I'm going to cube that. So it's going to be equal to 0 at 1 over 1/25. So what I've got is 0, 1 over 1/25. Let's go back over here. If you plug in negative values into this, this is going to be, ignore this for right now, this will be negative, minus a 1, this will be negative. Okay, this right here though, the cube root of a negative is negative, but the square there will make it positive. So it'll be a positive times a negative, so this is going to be negative. It's going to be concave down in that particular interval right there. Between 0 and 1 over 125, okay, this right here, I'm going to get the cube root of those numbers is still going to be quite small. It's still going to be 5 multiplied, that's going to be quite small, minus 1, still going to be negative. This is still going to be negative. It's going to be negative there. okay? And then over here, this will be positive, everything will be positive. So it's going to be concave down there, concave up right here. So what we're getting here is that the second derivative is going to be, let's start with negative on the interval negative infinity to 0, union 0 to 1 over 125, which means this thing is going to be concave down. Now bear in mind, it was undefined at 0. So it's still going to be concave down on negative infinity to 0, can't include the 0, but from 0 to 120, whoops, sorry, 125th here, and that's going to be inclusive. It's going to be concave up, or the second derivative is positive, from 1/125th out to infinity, which means this is going to be concave up on the inclusive interval from 1/125th out to infinity. And so finally, we got to look at points of inflection here. Whoops, points of inflection. But notice at 0, 0, the concavity doesn't change. Okay, so that doesn't count as a point of inflection. Actually, what we've got here is that we've got a cusp at 0, 0, which is interesting. We haven't seen that yet. So here we go. We've got a cusp or not necessarily a cusp even. Actually, at this point here, I don't even think this counts as a cusp. Actually, I believe this one is more of a corner. And you'll see why in just a second. At first, right now, though, it looks like a cusp, but I don't actually think it counts as a cusp at this point. And I might be wrong in that, but here, we do have a point of inflection here at the 1/125th because the concavity changes here. So we do have a point of inflection, and that's going to be at 1/125th here. And I got to go, again, right back up to the original to figure out what the y-coordinate is there. But I believe this is actually a little bit easier even to figure out here because this is going to be 1/25th. The cube root will be 1/5. So this will be 2 times the 1/5 to the 5th minus 1/5 to the 4th. Little bit easier than what we were just looking at here. We come over here, we can do the exact same thing. So this will be 1, 1. So it'll end up being 1/5 to the 4th multiplied by negative 1/5. So it's just going to be negative 3,125th. Negative 1 over 3,125. All right. So really, really, really small here. So now let's put this all together. What does this finally look like here? Let's take a look at our sketch. Okay, so we've got 0, 0 right there. We have got the point 1/25th negative 1 over 3,125. So that's going to be a little bit over here, not very far down at all. I have also got that maximum point at 8/125ths, negative 16, 3/125. That's going to be down here somewhere. Along the top of my graph, I'll identify intervals of increasing and decreasing. It's going to be increasing here, and then it's going to be, what was it, decreasing and then increasing. Along the bottom, my concavity changes, or at least there's an issue with the concavity at 0, 0, but it was concave down here, and then concave up. Really, really small here. Oh! No, I identified that wrong there. I'm sorry. That wasn't a cusp. The concavity doesn't change because that was a maximum. The first derivative goes to 0 up there. That's because that was a maximum. My mistake. I'm sorry. I wanted there to be a cusp so badly there. I wanted there to be a cusp that I didn't take into account that actually that's not what's going on there. So the second derivative is undefined there. That's because it becomes a very, very sharp kind of a point there, but it's increasing concave down, basically to like almost a sharp point there. The concavity becomes so dramatic there, and then it comes down. Okay, decreasing, still concave up. Then it changes concavity, concave up. Oh, I'm sorry, then there's the 1/8. I forgot about the x-intercept at 1/8. Then it's still concave up and increasing, and away we go. So it's going to look something like this, but this, I won't be able to draw that really nicely there. It's going to be very, very sharp point. Anyway, I hesitated there a little bit just because the numbers for this particular question here got a little bit beyond what I'm comfortable with, but I think I got the right idea. I hope that makes sense. I hope the graph makes sense. Sorry I jumped on that little thing with the cusp there. It's not. It was a maximum. Okay, remember that I've got that up here. Where's my max? I've got my max written right there. But it is, because the concavity becomes undefined there, it's really, really a sharp change.